Good morning, my dear student. Now we will discuss about the allotropes of carbon. Allotropes of carbon is the phenomenon of existing one or more forms of an element is called as allotropy. So allotropy is nothing, the phenomenon. That means the power for existing more than one form. That is what we call as a allotropy. Phenomenon of existing more than one form of an element is called as allotropy. And the forms are called as, and the different forms are called as allotropes. Now this carbon has two allotropes. This carbon has two allotropes, that is graphite and diamonds. In case of graphite, the 6 carbons atom are hexagonally joined to each other, so that one carbon atom will have one free electrons. Is like this, layer by layer hexagons will be formed here, is like this. Like this we will have like this. So each carbon atom have 3 bond pair and 1 single electrons, and these single electrons allow the flow of electrons, and thus graphite is a good conductor of electricity. So this is for the graphite. This figure is hexagonal, and in case of diamond, the carbon atoms are joined tetrahedral. So all the 4 valences are used. So there is no free electrons. And due to the absence of free electrons, this carbon atom in diamond does not carry electricity. So in case of diamond, the force of attraction is high covalent bond, whereas here weak van der Waals force. In case of graphite, the force of attraction is weak van der Waals force. Weak van der Waals force. Here strong covalent bond. So due to the weaker force, this graphite is soft and diamond is hard, and because of hardness, its refractive index is high as compared to this graphite. So here we know that case of graphite, there is a good conductivity and low melting point, while in case of diamond, bad conductor, higher melting point, and the force is weak, and here the force is strong. And because of that, melting point become different, and because of free electrons in case of graphite, graphite is of good conductor of electricity, whereas absence of free electrons, diamond is bad conductor of electricity. And because of hardness, it is used to make grinding tools or to cut your glass. Whereas this, because of soap and because of weak force, it become easily make it into powder, and because of making powder here, it is slippery, and because of its slippery properties, and it will have the use as a lubricating oil in the engines where high energy is required. So this is what about the properties difference between diamond and the graphite. So these are the allotropes of carbon. Not only these two, that is diamond and graphite, another that is fluorines, F-L-U-R-E-N-C. Fluorines. Fluorines is also another form of carbons whose structure is just like football. So fluorines contain 60 carbon atoms are joined in the form of footballs. So in the footballs you have seen like this one, like this joining is there. So like this different parts are joined together to make your football. So like this here, this is about the fluorines. So the properties of fluorines will not be discussed here properly according to your book. Now let us see your textual question. What would be the electron dot structures of carbon dioxide? So we have carbon dioxide here. Let us see it. First question answer. Carbon has 4 valency. So we will go 1, 2, 3, 4. So 1 oxygen has 6 valency. 1, 2, 3, 4, 5, 6. We have another oxygen here. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And this one, and 1, 2, 3, 4, 5, 6. So like this one, when this becomes here, it becomes 8, and when this becomes here, it becomes 8, and like this one, the carbon also will get 8 electrons. So these two is here, and these two should be here. So carbon also gets 8 electrons. So it is a electron dot structures of your carbon dioxide. So this is our question number 1 answer. That is linear structure. Linear structures. Now in the question number 2, what would be the electron dot structures of a molecule of sulfur which is made by 8 atoms of sulfur? So we can join sulfur here. Sulfur, remaining for valency you can put here. Like this you will get it. The electron dot structures means that is 1 you can write as like this one is sulfur. Is 9 you can make it electron remaining. Like this you can draw it. Lone pairs you need to put it here. Now this is what about the allotropes of carbon. Thank you.